So thank you for joining this session. We're going to talk about how we are using AI to do better remediation, better risk prioritization in the cloud. My name is Bar Schwartz. I'm a director of product management in Prisma Cloud in Palo Alto Networks. So I'm working on the cloud security team. And what we are basically doing is helping our customers be more secure when they are running their applications in the public cloud. AWS, obviously, very important part of it. So with that, I'm going to start maybe just by setting the context for a second to see what I'm exactly going to talk about, and then we'll jump into the details and talk about how we're actually using AI here in order to do this better prioritization and remediation. So very quickly, in Palo Alto Networks, we are the biggest cybersecurity company in the world, and we have many different areas where we are doing security. So we have our traditional network security part, which is all of our software and hardware and firewalls and SASE that we're running for our customers. These are our traditional businesses that we grew up. So that's our first business. The second one is our cloud security, Prisma Cloud. This is how we are protecting our customers, building their applications on the cloud itself. And we have our SOC or security operation with our Cortex solution. This is where we are helping our customers to have new approach to SOC with fully integrated data and automation, running playbooks and those kind of things. And we have our Unit 42, our threat intelligence and advisory services that are helping customers basically be more secured and when they are under attacks or publishing a lot of very interesting things. So definitely very recommended to look at those as well. I'm going to put this aside for now, just wanted to give you the context, and I'm going to be very focused in things we are doing in the middle in Prisma Cloud. And this is how we are helping our customers be more secured. So CNAPP is the space itself. So CNAPP is basically Cloud Native Application Protection Platform. Those are platforms that helping customers build more secure cloud applications or applications running in the cloud. And Prisma Cloud were pretty much the first solution that started and helped customers with those. And when we started, it was a lot of different configurations or policies that were looking at a lot of different things. So from things like looking at misconfigurations, do I have any misconfigured database or S3 buckets or IAM permissions, anything around identity, what type of data we're storing in the cloud, vulnerabilities that we have in our workloads. So we were checking those things very siloed, so everything were checked separately. And when we found that there is something that is important enough, we generated an alert and let you know, hey, there is a problem with your identities here or a problem with your misconfiguration, et cetera, et cetera. So a lot of silos policies, making a lot of siloed findings and alert in the system. And of course, doing the correlation or understanding the big picture was not that easy at the beginning. Not to mention things like prioritization and remediation. But then a few years ago, we shifted into what we call CNAPP 2.0. And this is where you saw the market starting doing those correlations or joint policies. So what do I mean by that? So instead of looking at this EC2 that is misconfigured and may be open to the internet, and an S3 bucket with some sensitive data, an IAM role with overly permissive access, we started to look at them together and say, hey, there is an actual path here. Like an attacker can actually go from the internet through this EC2 instance with the IAM roles and access the S3 bucket with sensitive data. So we started to stitch things together, and of course, very naturally, it makes a number of alerts or findings going down, right? Because now I don't have to alert about each and everything. What I can do instead is basically look at the whole thing, at the whole attack path, and say there is a problem here. So you have much less alert in this case, right? And we see a very big reduction. So the correlation itself, the correlation part, is now much more automated. But still, if we think about prioritization, what do we actually need to work on? What we are working on next? And not to mention remediation, those are things that still remain manual with a lot of manual work. So we were trying to think, okay, what's next? How we can help our customers better here and move from CNAP 2.0 to 3.0, where, as you can imagine, we're trying to more automate this prioritization and the remediation part. So obviously, the best approach maybe based on all of those technology advancements was to see how AI can help us in this thing. And in Palo Alto Networks, we are integrating AI in a lot of different areas in many of our different solutions. But here is really to say how we can use AI, leverage AI in order to be able to detect better, be able to automate the prioritization, and then also help with the actual remediation. So if we think about what is actually needed here, right? There are three main things that we were thinking about. First is, are we continuously monitoring and detecting anomalies and breaches in the cloud itself? And continuous is the key word here, right? Is the main thing. Then how do we analyze it and understand incidents the moment they actually happen? And the third is, how do we able to mitigate or even remediate some of those, hopefully without human intervention, or at least many of them. So those are the three things. So as I mentioned, we're trying to move from this CNAP 2.0, when still prioritization and remediation is manual, into how we're doing it more automatically. So for that, we thought a lot, and we came up with four main things that I'm going to tell you about today. First thing is, remember those attack paths I mentioned before? The fact that we're able to correlate or stitch together things in order to tell you like a better story of an attacker that can go from the internet, through the machine, the workload, all the way to the sensitive data. We are working, or we were working on doing those things automatically and using a lot of AI. So trying to be able to take this massive amount of data and understand how we can stitch together to actually tell a story of a real attacker that can attack your cloud environment. The second thing is blast radius. So what is blast radius? Blast radius is where you are basically landing, or an attacker land somewhere in your environment. We are doing a calculation to understand what then. So let's say that an attacker can get into one of your workloads, your containers. Then what? What this attacker can do next? Can attacker leverage things like the network connectivity, API calls, permissions, all of those together in order to lateral move within your environment? So blast radius is a project we are working on that basically do this, trying to land somewhere in the cloud and then try to find all of the different paths for an attacker. And then there are two main things that I'm going to be focused on today. One is improved risk prioritization, and I'm going to talk a lot about it. So risk prioritization is basically the ability to say those things are more important than others, right? And it is very important because if we find a lot of things, and we want to let you know that we find a lot of things. We want to let you know, hey, we are able to scan your data, we're able to scan your vulnerabilities, we're able to scan misconfigurations, we're able to scan a lot of different things. If we're not able to tell you what are the things you need to work on, then you just have a bunch of issues that you need to handle yourself. And then the last thing are the action plans that I'm going to talk about that is going to help with, that are helping with remediation and fix those issues. But not only that. I'll talk about it in a second. So that was our approach to move from CNAP 2.0 to 3.0 that I showed before. And we were thinking about those four projects and started working on it. And I'm going to share with you the progress and what we were able to achieve with that. I'm going to jump to the end for a second in order to tell you that by leveraging AI here, we were able to reduce the number of alerts and the time it takes you to triage and remediate by 20x. That's a huge number if you think about it. I guess you all somehow part of a security team or related somehow to security, and you understand the shortage in the security staff, you understand how much time or effort do you need to put in resolving those things. If we're able to reduce by 20x the time it takes you to resolve those issues, this is huge. So those projects, again, we leverage AI in order to do this, and I'm going to share the details in just a second. All right, so how do we do this? So there are three things that we thought would be the best approach in this case. And again, the ultimate goal is to help you reduce risk, eliminate your risk. It might be even mitigate your risk. I'll talk about the difference in a second. But the three main things is, first of all, prioritize. If you don't know what we need to be focused on, then there is no there's no meaning for actually running automations or trying to remediate or whatever. So prioritization, I think we all agree, is a very important first step here. Then we have building a strategy. Okay, so let's assume that we have 10,000 alerts in our system that Prisma Cloud were able to find for you, that like misconfigurations, vulnerability, whatever. If we are able to prioritize them, it will be prioritized, which is much better than it was before, but you still have 10,000 issues that you need to work on. So just keeping it as is, or just giving you the prioritization, which is what we see with a lot of products today, it's not enough because you still have a lot to work on. Yeah, you're probably going to prioritize and work on the important things first, but our main goal is to actually eliminate the risk, right? Or burn down those issues to zero. So the next thing is building a strategy. Understand really how we can look at those alerts and work on them more efficiently in a much better way. And I'll share the details of this in a second. And of course, the last part is the execution itself. So we want to actually execute. We want to fix the issues. We want to make sure we're not going to have the issues anymore on our environment. Okay, so let's go one by one, see what we were doing here, how we leverage AI for that, and then at the end, I'll show you a quick demo of those capabilities. So prioritization, let's start with that. What we were doing, or what we were thinking, is just looking at our policies or things that we are finding today in your environment is not enough. And let me give you an example, right? If I'm looking at an S3 bucket in your cloud environment, in your AWS environment, let's say that this S3 bucket is not encrypted. So based on the configurations of this S3 bucket, it is configured not to be encrypted. Probably you want to know about it. Probably you want to encrypt the data in your S3 buckets, right? But how important is this thing? So we can try to estimate what might be the severity here, or what could go wrong if an attacker would leverage this thing. But how important is really working on this thing? And the answer is it really depends on the context. So there might be an S3 bucket, and this S3 bucket might be in a production environment. It might be, of course, it is unencrypted, right? This is where we started. In production environment, with sensitive data inside, it is public, open to the internet. Of course, this unencrypted bucket is much more important than another S3 bucket, which is a developer left open in like a dev environment, no data inside, no one can actually maybe access it, no IAM permission or whatever. So if you think about it, those two S3 buckets are unencrypted, and we don't want to tell you that you have two S3 buckets that are encrypted. We want to tell you there is one that is very, very important and you need to take a look at, and there is one which is just there. Maybe you need to take a look at some point, maybe not at all. So it is all about the context, and this is what we were doing here with the risk prioritization. So first of all, we have all of our security issues that we are looking at, we are generating. So if you think about it, first we are looking if you have any active attacks in your environment. So we have our defenders that are integrating with your workloads, your containers, your virtual machines, your serverless functions. And this is where we are getting some information about any potential active attacks on the machine itself, on the APIs of the machine exposed, and those kind of things. Second, we're looking for some anomalous activity. So it might be that we found right now someone trying to connect to your environment from a place where we have not seen in the past, or like a lot of API calls to a specific service in AWS that we haven't seen in the past. So those kind of anomalous behavior is something else we're looking at. And then there's all of the other findings that I mentioned before, looking at data and vulnerabilities and misconfigurations and secrets and overly permissive roles and et cetera, et cetera. So we take all of this, and as I mentioned, this is not enough. So in the next step, in number 2, we are enriching those insights. We're adding context to those issues that we're able to find in step number 1. So again, we will look at things like, where did we find the issue? Prod environment or dev environment? Is this open to the internet? Who has access to it? What is the usage volume of this thing? If this is a vulnerability, what is the CVSS score of the vulnerability? right? So we're looking at a few things. One is the security attributes. Security attributes is exactly as I mentioned, things like CVSS score, how risky is a specific thing. And we have a lot of measurements of doing this. Another one might be the asset attribute. Is this asset in a dev or prod environment? Is this asset open to the internet? So looking at the asset itself. But everything I mentioned so far is pretty generic. So this is something that we can do across all customers. But we know that each and every one of you have their own environment, and you're working differently. So some of you might have very good tag hygiene, so you're putting some tags to mark all of those crown jewels or the important things in your cloud. Some of you using some prefix in the name. Some of you using specific regions that are more important. So each and every environment is different. And this is why we are also looking at the customer-specific attributes. So the customer-specific attributes looking exactly at this. It learns over time what you're doing in your cloud environment and understand what are the important things for you. We're looking at your tags and understand, hey, there are some tags that are telling us that this is more important than other things. We're looking at some prefixes and say, okay, we see that if there is this prefix in your for your workloads, it means that it is more important for you. How do we know this? We look at your cloud logs, we analyze your behavior in the cloud, and then we really understand what is more important or not. You can, of course, tell us explicitly if you want, but we learn this over time. Then the third thing, after we have the full context here, is to try to do the risk prioritization. And this is where we use AI and ML in order to do that. So we are building models or trained models that basically learn the behavior, again, both globally, but also customer-specific. And we're able to say, this bucket, based on the context and what we know about it, we think that this is very, very important. And not only that we are telling you that it is very important, we're also able to give you an explanation of why we think this is important. If you're familiar with a lot of security tools, some of them will just, tell you, hey, there is here's like an issue, here's a score, 90. All right, 90 is more important than 70, I get this, but why did you give this 90 and not 70? Or why do you think this one is more important than other things? So this is something that we're doing, and our algorithms, and again, using AI, we're able to explain why we decided that something is more important than other. So that's for the risk prioritization. We build this thing, and then we immediately were able to see that now we're able to take all of the amount of alerts and issues that we found in your environment and tell you based on the context what is important and what is not. Okay, so let's move on to the next part. And the strategy, as I mentioned before, is very important because, again, if you have 10,000 alerts before the risk prioritization, you still have 10,000 alerts after the risk prioritization. You probably know what you need to work on first, which is great, but our ultimate goal is to reduce the risk as much as we can, right? So this is why we build a strategy. Now, if you look at the cloud environment, there are some ways for you to really understand what is more, I would say, both more important than other, obviously, but also there are sometimes some common paths or common issues that can cause multiple different security risks. So let me give an example. Let's say that we found an attack path. Again, attack path, you have an attacker going from the internet through your workloads to some sensitive data. Now, maybe what's made it possible is both a configuration of the EC2 and then some IAM role that the EC2 is using, et cetera, et cetera. Then you have a serverless function, maybe a Lambda function, that is able to use an IAM role, and then there's some combination of permissions in this IAM role allowing it to gain more access, for example. Now, if you look at those two things, those are very, very different two things, right? One of them is about an attacker going from the internet, another one is privilege escalation to your environment. Very different ones. But it might be that both of those attack paths using the same IAM role. The same IAM role is being reused by different workloads. And this is something we definitely see on our customer's environment. Now, if you have one IAM role that is common across or being used by many workloads, why don't you go and fix this role, and then many of the issues that you have in your environment will be resolved. So this is what we did with the action plans. we're looking at your environment and we're trying to say, all right, based on all of the different, based on all of your different issues that we were able to find, is there a better, more efficient way to work on them, to fix them, instead of just looking at them one by one? So one approach would be, I see an issue, I'm trying to understand how do I fix it. I see the recommendations in Prisma Cloud, I'm taking the recommendations, problem fixed. Now I have one less thing to worry about. But with action plans, we are telling you, see, we found an IAM role here. We found an image. We found an EC2 security group. We found some assets that are common or being used across different assets, other assets, that if you fix them, you're going to resolve multiple issues. And those are action plans. Action plans allowing you to basically do this. Action plans allowing you to fix things much more efficiently than going one by one. And again, we're using AI technologies here. So the example I provided of how to, like the one IAM role that can fix multiple things is pretty straightforward. But when you have thousands of issues and you have a lot of them in the cloud, we are using or leveraging AI to understand how we can stitch them together or group them together and find the root cause that will help you to resolve most of the issues together. And I'll show you an example of the demo in just a second for those capabilities. But just by doing this, we're able to reduce the number of alerts significantly because you don't have to work on alerts one by one anymore. We group them together, and now we're telling you, go fix this. It will resolve multiple issues at once, multiple alerts at once. Now, last thing, it won't work anything if we just do the old prioritization, grouping, etc., without being able to execute, without being able to actually resolve the issues. So that's why we are working on the execution part. And the execution part, we have a few important things here. One is, and I guess you all, if you're working as security engineers or DevSecOps, you know that a lot of time the first immediate step for you would be to find the owner. There is a problem, there's a security problem, there's security misconfiguration. Who is the owner? Who is the one that can actually go and fix this issue? It's probably not going to be the security engineer, it's going to be a developer or development team or DevSecOps who are actually going to fix the issue. So finding the owner is a very important first step. And what we were doing is, when we're generating an action plan, immediately, based on a lot of different logic, we are able to find the exact owner. We are able to say, this is the team owning this asset, and therefore, if you want to execute or if you want to take action, this is the team you need to talk to. Or even better than this, that I'll mention it in a second, even send them the information automatically without even my intervention. Second thing is some quick actions that we can take. We are talking, obviously, and very focusing on remediation. Remediation is fixing the problem. So I have a vulnerability, now I don't have the vulnerability anymore. I have an EC2 that is exposed to the internet, the EC2 is not exposed anymore. This is the remediation part. But many times we do have the option to do some quick things that will make the situation better, still not remediated completely, but will make the situation better. This is what we call mitigation. So what do we have in mitigation as an example? We have a publicly exposed EC2. Instead of completely removing it, or we have a vulnerability, instead of redeploy the image without the vulnerable package, etc., it might take time. In the meantime, let's have a firewall that will protect our workloads. Let's have protections to our APIs that if we see someone trying to leverage this vulnerability, we will block them immediately. It is not going to resolve the problem. You still have the vulnerability. But we're able to protect you while you're doing the right thing and fixing the issue. So running some quick actions that will make the situation much better, like mitigation, is something that we're able to do here in this execution part. The next thing would be every customer is fixing those things differently. Some of you might prefer to get those remediation recommendations in a Terraform script. Some of you might want to get like the actual steps that you need to do in the console or CLI commands. Some of them would want to create their own scripts, and you want to run your own scripts because you have some workflows already to fix some issues in the cloud. So we are enabling you basically to do those things, to bring your own stuff, or to get the recommendations in a lot of different formats. The next two things I want to talk about, one of them is prevention. Prevention is super, super important. Once we fix the issue, how do we make sure that we're not going to have this issue in the future anymore? And again, if you think about it, we can fix those log4js that we have in our environment. If developers will continue using vulnerable versions of log4j, we will continue having those vulnerabilities, and we'll have to go back to the developers and ask them to fix it again, and vice versa, right? And so on and so forth. But if we are able to fix an issue and then also prevent the issue from happening in the future, that would be amazing, because not only we fix this one issue, we also prevented issues from coming on in the future. So being able to prevent things, and in Prisma Cloud, we're able to integrate not only with your cloud environment, not only with your AWS environment, but we're also able to integrate with your CI/CD pipelines and your code or code repositories. When I say code, like actually the IDEs of the developers. So we're integrating with a lot of different areas in the pipeline. And then, for example, with our integrations with your CI/CDs, we're able to say, OK, let's fix this vulnerability that we see right now. We redeploy the image not to have the vulnerable version anymore. But also, in the CI/CD pipeline, every time we see a developer trying to push this package again, which will obviously cause this vulnerability, we want to fail the build. All of those things are things that you can do very easily from Prisma Cloud. And the last thing is our tight integration with other solutions from Palo Alto Networks. One of them is Cortex, that basically allowing you to create a lot of playbooks that you are able to run when you see one of those issues. So we found out that we have here an overly permissive role. All right, what are the steps that we're going to take? And we have this deep integration with Cortex XOR, which is another solution by Palo Alto Networks, where we are able to trigger some of those playbooks and say, all right, what are the steps that we need to take every time we understand that we have an overly permissive role? And this is the world of automation. This is how we're able to fix things without your intervention, and we're able to basically make you focus on the most important things. Let's jump to the environment. I would love to show you a quick demo of the capabilities. So here I'm in the Prisma Cloud console, and I'm in this tab called Action Plans. So this is what I was talking about, the ability for us to group those things together. Let's take a look at a few examples. So what we can see here, the first one, is we're telling you there is an EC2 image, all right? So it's basically an image, and we found that there are 24 alerts that we generated, or vulnerabilities that we found in our scan, that were all caused because of this one IAM image. Now, what we can tell you more is that this image is being used by 3 different EC2 instances. So basically, you define this image one time with vulnerabilities, then you are using the same image in different EC2 instances, and basically create more and more risk in your environment, because those vulnerabilities now duplicated across those 3 EC2 instances. We can show you those 24 alerts that we're able to find that we group here together, and we're telling you exactly how to fix them. Now, before action plans, as you can see here, those 24 alerts, before action plans, what you have to do is to go to our alerts page and work on those alerts one by one. Look at alert number 1 related to vulnerabilities, fix it. Then go to alert number 2. And of course, if you have thousands of those alerts, where do you even start? And how do you know that those alerts are even related to each other? How do you know that all of those alerts are basically because of the same image? Let's see another example here. The second example is that we have an EC2 security group, and this security group basically causing 45 different alerts in the system that are related to internet exposure. So again, we can take a look at the assets. We have few assets using the same security group. We have 45 alerts in the system. We can maybe take a look at one of those alerts. So this one, for example, is an attack path. I'll make it bigger so you'll be able to see. Here we have the EC2 instance. It has a vulnerability. And we can also see how this EC2 instance through the ENI, the subnet, the VPC, et cetera, is open to the internet. Now, this is only one problem, but in this specific action plan, we have 45 problems like this that are very different. But all of them can be resolved if you are only going to fix this one EC2 security group that we're showing you here. And you can see the full information, where is this, and all of the other information of this specific EC2 security group. Now, one interesting thing I would like to mention here, you see that for the first action plan, we have 24 alerts. For the second action plan, we have 45 alerts. And if I sort here by criticality, the system basically telling me that fixing those 24 alerts or having a fix that will fix 24 alerts is more important than having another fix, single fix that will resolve 45 alerts. Why is that? Remember we talked about risk prioritization. In this case, we understand that those 24 alerts are more important than the other 45 alerts for the second action plan. So in both action plans, you're going to take one action, resolve 24 alerts, or one action to resolve 45 alerts. But we're still telling you, go do and fix the 24 alerts before you fix the 45 alerts. Why? Because the 24 are more important. Because we understand the context, we understand that it might be more crucial because of different attributes that I mentioned before, and therefore you should go fix this first. I'm going to show last example here. And this last example here is going to be on IAM. So in this case, we have an IAM role. Again, this IAM role, 24 alerts related to privilege escalation. This IAM role is being reused again across multiple EC2 instances. So same one IAM role across multiple EC2 instances. And therefore, we found a lot of different issues. So here's another another attack path. So in this case, we see that we have an EC2 instance open to the internet. But in this case, the main issue here is this one IAM role attached to this EC2 instance. And this IAM role allowing it or as some combination of permissions that is risky. In this case, IAM pass role and IAM SageMaker IAM permissions, which together might allow you to get more permissions or have the risk of privilege escalation. Now, this role is being reused in a lot of different other areas in your cloud environment. Some of them in different attack paths, some of them, as you can see here, completely different attack path, or some of them might be some misconfigurations of the IAM role itself. But if you only go to this one IAM role and fix it, 24 alerts are going to be resolved at once. Before action plans, you have to take 24 different actions. With action plans, we are able to tell you, take this one action, it will resolve 24 things together. And we're using our precision AI mechanism here in order to do this. And basically to give you the right remediation steps, and I'll give last example here. If you have one attack path, as we saw here before, that has some permissions, let's say A and B for this role, that needs to be removed. And then there's another attack path at the same role, but for this attack path, in order to resolve it, you need to remove permissions C and D. So action plan will take those two together and say, okay, this is the same IAM role. The permissions are different, so now I understand that if to resolve one, we need to remove permissions A and B. And to resolve alert 2, we need to remove permissions C and D. Overall, we need to remove permissions A, B, C, and D. Now, this is a very simplistic approach, obviously, and example. But we are leveraging AI and generative AI in this case in order to understand here are different issues, all caused by the same asset, but the way to fix it is very different. We want to take everything together and get steps, a full list of steps that I need to take in order to eliminate the risk. All right, so with that, I would like to invite Jeff to the stage. Jeff is a principal security architect for EchoStar, and we'll have a quick side chat to talk about Prisma Cloud and talk about what I've just shown you. Welcome, Jeff.
Thanks, Bar.
All right, great. So yeah, why don't you start just by introducing yourself, your role at company?
Sure. Yeah, I'm Jeff Philippi. I'm a principal security architect at EchoStar. Our company, we have several businesses. You'll probably be familiar with them. Dish Network, which is our pay TV company, Sling TV, streaming company. We have Hughes, which is a satellite business. We also do OnTech, which is a service that installs things in your home. We also have 5G network, a 5G cellular network under Boost, and Boost is cloud native, AWS built on top of AWS, and those are the services we offer to our customers.
Great, yeah, and tell us maybe a little bit more on your cloud usage, even before security and anything we're doing there. Like, how's your environment look like? What are the things you're running there? Like maybe about the workloads and the scale that for your customers.
Yeah, so the history is we started with company Sling, cloud native streaming platform. That was in AWS, still is, and we have added to that over the years. We've recently, in the last few years, have built the 5G network in the cloud, cloud native on AWS. We also have other lines of business that we talked about are also in the cloud. We have a large AWS footprint, more than 1,000 AWS accounts, multiple control towers. Yeah, so.
Perfect. And tell us maybe a little bit more about the workflows and like how like engineers working on the templates and IC and the code, collaborating with DevOps, collaborating with security engineers. How does it look like in your organization?
Yeah, so we have thousands of developers, hundreds of teams. They're building for the different lines of business, and some of them use a lot of automation, the Terraform or CloudFormation. Some of them do things manually and kind of go to the console. We have regular agile development, where people will come up with product ideas, product features, and get them into the queue. We've recently been, in the last several years, have been adding DevSecOps into the DevOps pipeline. So the ability to scan people's code to be able to do, take the findings, and then we talk about all the prioritization strategy that you talked about earlier. But
yeah, perfect. And maybe before we jump into like cloud security and the things that you're doing there, why in general, and you have a lot of experience in security in general, why do you feel that cloud security is different than traditional security? What is unique about it?
Yeah, there's ways that there's things that are similar and there's things that are different. I think the things that are similar is regardless of where you deploy your code, you have code to manage, you have to manage the security issues of the code. I think what's different is we have more visibility in the cloud. There's APIs for everything. It's easy to integrate products that can call those APIs and tell us if there's something misconfigured. On premises, it's a little bit different. We have both, so we're a hybrid environment. So on premises, there's more legacy. There's more, it's more up to like your ability to maintain your asset tracking, versus in cloud, the assets are all tracked. They're all tracked. They're all billed. Amazon, you just have to make a call to get the assets that you need. So in some ways it's easier, but it's also more distributed. Like on premises, you've got your data center team, and they're responsible for racking equipment. In the cloud, we've given very distributed access, so a lot of teams can create cloud assets. So then it's about your processes. Can you keep your processes under control and in all the different environments that we have?
Perfect, thank you. And what's kind of like day in the life of I would say a security engineer in the cloud? What are the things that are important? What are the things that you are doing? Are you more working on kind of bigger projects or bigger goals? Are you more looking at trying to actively find risk? What does it look like?
So yeah, we do have different teams in security engineering. So we'll have DevSecOps and SDLC team that works on the code issues, and that team's been really helpful for us in developing the process for how to fix issues in general, right? So they're really good at fixing issues at scale. Some teams have maybe 20,000 vulnerabilities in their code base. Mm-hmm. They can handle that. It's not easy, but they found a way to handle that, and we could talk about that. Other teams are looking at cloud misconfiguration and going in and what they're a lot of the times they're doing is someone says, hey, I need access. My access isn't working. Please fix my IAM permissions. So it's very difficult for that team to keep up with that workload and then to go and actually go out and look for issues. So we have a variety of teams doing engineering and security, and those are the kind of days they lead, right?
Perfect. And would you mind sharing a little bit maybe of how it is to, I'm looking at things from the provider trying to help make things a little bit easier, but maybe just to understand before those kind of solutions, before CNAPP, before cloud, how does it look like? What you were doing, how you were handling those things, how you were able to find stuff and risk in their cloud environment before having like kind of a solution that helped you with that?
Yeah, so when we started in cloud quite a while ago in Amazon, we didn't have these solutions, right? So we would have to do our best, and we had like really just one or two engineers who really knew security and the cloud, and they were just always catching up, trying to catch, like what's this team doing? How do I find out more about what they're doing? We didn't have even some of the native solutions that are possible now, so it was more like a scavenger hunt almost, like where's the security issues, where can I find them? Then we started building in solutions like Evident.io, which is now part of Prisma, and where at least we could see what the issues were in the cloud, right? Just what the findings were, and that's similar to some of the native solutions like Security Hub and Guard Duty and all that, and so those are helpful. Like at least you can have visibility, but visibility doesn't actually fix anything. So you have to go beyond that. And then also our journey on SDLC on the DevSecOps. Originally we just had a team in QA, and they would just scan when the project was in test, and they would scan and do like basically a dynamic pen test, and they would try to find what they could break, but it was fairly far right. I mean, this is about stuff that's about to go to production, and there's very little time to fix whatever you do find, right? Or else block the product going to production. So fast forward a little bit, and we've added the ability, a full SDLC, shifting left, the ability to scan code in the developer's editor, right, to fix it in place, right? And I think that's where this needs to go. But it's also, you can't put it all on the developer. We have to also put things in the pipeline. So when the pipeline's running and the code's building, we scan that. If there's an issue, we can even block the deployment. And then same thing with the cloud. I mean, now that we have more visibility, what do you do with the visibility? Like, how do you actually get the issues fixed? And I think that's where we're talking about the journey of, similar to where Palo Alto is going. We had this idea that, I can't just give a team a spreadsheet with 20,000 findings on it. They're not going to know how to react to it. They're not going to know how to prioritize it. So what we've done instead is very similar to what I'm seeing in action plans, where we're prioritizing. So we're doing analytics on the actual vulnerabilities, finding out who the fix team is and analyzing it from their perspective. So when we go to a fix team now, we want to go to them with an actual concrete plan. These are the 3 things you need to fix to reduce the risk the most. And it's not based just on vulnerabilities. What we're looking at is, what is the thing that you do to fix the vulnerability? And does that fix in common with other vulnerabilities? Because a lot of times if it's OS upgrade or something like that, if you can just fix the OS to the right version, then the vulnerabilities are all taken care of. Not all of them, but the majority of them. And that's one action that you can take. Also, if you look at, maybe I have this vulnerability, but I have it in multiple projects, right? So let me fix the same vulnerability in all the projects. That's very efficient for a development team, because they might use the same template or the same skeleton to generate their code. And if you say, this is the fix I need you to do, I want you to update log4j, maybe that means you update Spring Boot, right? So what we do is work with the teams to figure out what's the right solution for them. Maybe it's a Spring Boot update that takes care of all the vulnerabilities that we're looking at.
Yeah, no, makes sense. And I would like to comment on 2 very, very important things that you mentioned. So thing number 1 is, our code is very important in this whole thing, right? When we think about the public cloud, we the first thing we're probably thinking about is the AWS environment, the infrastructure itself, maybe runtime as well. We're protecting our workloads, our virtual machines, containers, serverless. But what we see when working with a lot of customers is code is so important because at the end, if we find something in production environment, right, and you mentioned this right, then going back, find the right team to fix it, help them prioritize, make sure they're actually fixing it, then redeploy it, then we verify that the problem actually resolved. It takes so much time that if we can prevent things from even going to the production from the first place, right, it will save so much time. And this only can be done if we are looking at the code itself and we're able to block things very early in the pipeline.
For sure.
Yeah.
Yeah, code security I think is fundamental because everything that's running in the cloud is based on your software, right? That you're writing, and a lot of it's libraries. So it's only a fraction of it is the code that the team develops themselves. The iceberg, the tip of the iceberg, but the entire iceberg is all the libraries and things that you're pulling in. And if you don't, the good thing about code is you know who wrote it. You know what team. Every single line of commit has someone who is responsible for that in source control. So you can, in the code, you can get down to the fix agent pretty quickly and get that person engaged and understand their workflow. And what do I need to tell them? What do I need to share with them so that we can get their code fixed, right? And in an efficient way, because developers are a scarce resource. Even if you have a lot of them, they're busy. They don't have time to waste, right? And when they're doing security, that's time they don't have to do other things that we want them to do for the business. So you have to be very efficient and effective with the developer's time. And that means for us, like getting into their workflow, when is your sprint schedule? When do you want this in your sprint so that you can get it done for us the fastest? And it's combining efforts. So like aggregating and collating everything that's happening down to one action. So it's like just fix the one thing. If it's a Spring Boot upgrade, if that fixes everything that we're looking at or all the criticals, then do that. That's the main thing we want people to do.
Basically want to make the most impact, right? We know that we have this much of time that we can put in resolving those issues, and we want to make the most out of it. So this prioritization part that you mentioned is also very, very interesting, right? Because what we see from many of our customers, and you described this as well, a lot of manual work, working with spreadsheets, trying to correlate things, trying to understand what is the risk. So a lot of work that, we are like in this whole conference talking so much about AI that it would just make sense that this will be work that someone else will do for us and just, give us the right prioritization.
Yeah, I mean, I think a lot of what we're seeing can be automated, but it is a lot of manual work to get to the point. I think learning where all your teams are, learning your business and who do I need to talk to get this fixed versus that. I mean, we might have an issue that's on a load balancer.
Yeah.
And in the past, we would have gone to the development team to say, hey, can you fix your TLS version? They don't fix TLS versions. That's not what they do. So the ability to uncover, like with tagging and other techniques you can use, where you can actually understand who owns everything, right? Mm-hmm. Like the ability to do that and to dynamically have your system understand that so that it can, so that we can assign things to the right team the first time instead of having them bounce around through teams. So I think there is a great promise of automation here. The ability to, the things that we were doing manually that we're looking at not having to do anymore, like the prioritization, like correlating all the fixes into one fix, right? All the issues into one fix. There's a lot of promise there to reduce that manual work that we have to do there. And then the strategy, getting those fixes aligned to the teams through like ticket management systems to say, this is the first thing we want you to work on from security. This is the second thing. This is the third. Please prioritize it accordingly. Mm-hmm. Get it into your sprint. That's the way that we're going to get these things, the way that we have gotten them done. And there's definitely a lot of opportunity for AI and automation to make that easier. It's not super complicated. It's just the volume is immense, right? So if, with a few rules or a few like basic guidelines or some automation code, some of this stuff can be built out, I think. And that's what we're looking for.
Definitely, and thank you for sharing this, because I think that this is definitely what we see like across our customers. This manual work, the ability to, or the need to prioritize, to understand what are we going to work first, and also what is going to make the most impact. This is common across all of our customers, and this is exactly what we had in mind when we were thinking about action plans. Because with action plans, we're both trying to group things together, and then basically telling you, hey, like, do this fix, it will make this much impact instead of like a very small impact. And also the ability to take some actions. Some of them might be automated, finding the owner, for example, which might be simple. It might be that you have kind of a, kind of manual playbook that you are following, and say, yeah, like I'm going to, if this is from this repository, it's probably going to be this team. If this has this specific tags, it's going to be this team. So you probably have kind of those things that definitely can be automated. And then the last part is like, yeah, how we are fixing it. And we know that different customers using different type of fixes. Some of them prefer to read in code, as you mentioned, which we believe is the right thing to do. Go fix it at the source, go fix the right templates, the IC, infrastructure as code template, or run any type of other automations that you feel that would make sense for your organization. So thank you for sharing this. So think about action plans and the things we are building. I guess saving time is obviously the main thing here, but what are the advantages that you like in general see for this one?
Yeah, so for action plans, I really like how it's evolving because it's aligning with our strategy. The idea of concentrating the fixes and getting them down to what is the essential fix that's going to move the needle the most. That's where we're at, and I think that's where it's great to see the tools coming, coming with us, and because really that's the name of the game. Like we can't just go fixing hundreds of thousands of issues one at a time. We have to do a bulk change. We have to do things that are smart, right? We have to do things that are effective, and that was one of the problems we had early on. Is that we had the visibility. Once we got the visibility, we didn't know what to do with it, right? And the ability now to so we had to come up with a plan, like how would you prioritize fixes? Like if you don't just go by the score. We tried going by the score, right? And just doing like, we'll fix all the 9.8s, right? And then we'll go to the 9.7s. And the problem was there's a lot of them, right? And if you fix them one at a time, you'll never make any headway, right? Mm-hmm. So the ability to consolidate that and be able to tell a story and get it to the right team, because they always ask like, well, why should I do this? I mean, I have other things that I need to do. What's the big deal, right? And to be able to tell the whole story, like with the things like attack path and blast radius, and being able to say like, this is the reason that you need to do this right now. It's more important. We have to go and say, this is sometimes more important than one of these things that you're working on for the business. Mm-hmm. And that is a big decision to make. So you want to be able to do that, but to be able to do it at scale is really where that's the promise, right? Because right now we can do it, doing it manually, doing a spreadsheet. We can handle about 20 teams a month, but to be able to, we have hundreds of teams, right? Mm-hmm. We want to be able to handle 200 teams a month. And to be able to do that, we need automation. We can't do it. We've gotten the system working, but without the automation, you can't scale out.
Yeah, definitely. And this is definitely what we have in mind when we are building those things like action plans and the ability to. You mentioned before, like previously, and we see a lot of customers doing it, like, hey, let's take this CVSS score and everything up to this score we are going to, or above, sorry, this score we are going to fix. What action plan will allow you to do is, even if you have those type of processes, we can tell you, hey, you know what? Yeah, go fix this one thing. But by the way, if you go to this image and do the following, right, or bump the version of multiple things, not only that you're going to solve this very high criticality or critical issue or vulnerability, you're going to solve much more than this. And you're going to take the same amount of time that you already are going to put in resolving this one vulnerability to solve multiple of them. So there's another flow that basically helping here to be more effective.
Yeah, that's really powerful, because that's kind of what we had eventually learned how to do is we're not just going to look at the vulnerability, we're going to look at the fixes, right? What is the thing that fixes the highest criticality vulnerabilities, and by the way, what else does it fix, right? Because if you look at everything with a common fix, then you can prioritize in that group. And that group with the common fix helps you understand which fix do you want to go after, right? Because I think that's the problem that security teams have, is they look at it from a security team's perspective, but in order to get things fixed, you have to turn the table and look at it from the fixed team's perspective. Mm-hmm. Like what is the level of effort for them what's the thing they can do that's going to, like you might tell them to fix log4j, but like you said, they might have an image that has the wrong version on it, right? So if you fix the image, you fix log4j plus a bunch of other things, right? So let's have the team, and they might, if you have a conversation with them, they may say, well, it's actually, what's that? Like, how do I fix log4j? Like, what do I actually do to change it? And you might tell them like how to change their POM file or something. But if they're like, well, actually, I was going to do a Spring Boot upgrade anyway, maybe I'll just do that, and then that'll fix all those things.
Yeah, yeah. So you're now in the process of like leveraging those action plans. So what are you going to do with all of the free time now?
Well, I don't know if you'll ever have free time in security, but I think the main thing is we'll spend the same amount of time, which is a lot, and then we'll get a lot more output out of it. I think the other thing too is we might be giving the developers more time back, because instead of pinging them on every single different kind of issue, which is something we found that has been very appreciated, is like, we're not going to tell you like fix every vulnerability. We're going to tell you do this one fix, right? Which is about the same amount of work as actually fixing like a vulnerability in one piece of code. Definitely. But you can do it hundreds of times with the same level of effort. So I think what the big picture is, developers will have more time to develop business features and ship more things for the business, and they'll still be running more secure code. And also our team that does, teams that do infrastructure, they'll have more secure infrastructure that the code runs on. So I think and they'll have more time back to do other things. So I think security team will always be fully busy, but the outcome will be that we'll have better security for less, spending less of the company's resources.
Yeah, and for the developers, I guess the context switch is something that is super, super important. I mean, if you can tell them, go to this IAM role and fix those 1, 2, 3, 4 things, right? They need to understand the role, need to understand who's using it, what is going to be the impact. There's a lot of things that they're doing outside of the fix itself that if they need to do multiple times because they're working on one issue in the role and then a week later another issue in the same role, we're just saving this all context switching. So this is another very powerful thing here.
Yeah, I mean, the correlation and the aggregation really helps keeping the developers on task, and they don't have to switch around. Like it's not a big deal to fix, to do Spring Update 100 times, but it's like to do 100 different issues, that's a big difference, right? So if I tell the team, you got maybe they've got 50 microservices and we need you to upgrade Spring Boot in every microservice. Once you do a couple, it's not that hard to do the rest, right? And they're staying on the same mental space, right?
Exactly.
But but if you say, well, we have a bunch of different issues and they're all over the place, and some of them even aren't for your team, and they have to go research. Once you do the research, you just want to do it once,
Definitely. Perfect. Anything else you want to share with the audience?
Yeah, I mean, I think the vulnerability is very hard work, and fixing these things is hard. But there are ways to make it a lot easier and a lot more productive. And I would think that the other thing I see teams struggle with is they don't know what to do, so they don't do anything. They go out and do a lot of research, but they're not fixing anything. And that's one of the things we had with our vulnerability program is like, you've got to get to fixing things and you got to get the risk reduced. Then you can iterate, right? You got to have a process where the risk is reduced.
Perfect. All right. So with that, I would like to thank you so much for joining me today, and thank you so much for attending this session. We'll be here if you have any other questions, and thank you again for attending.